Okay. Well, can you hear me from the last rows? Okay, thank you. Well, hello everyone, and thanks for being here, either in presence or online. I am Salvatore, a PhD candidate from University of Genoa and Fondazione Bruno Kessler in Italy. Me and my colleague, Matteo Rizzi, junior researcher at FBK, today will present to you the tool we brought together with Giada Sciarretta and Silvio Ranise, titled A Modular and Extensible Framework for Securing TLS. Basically, the paper describes how we went from a standalone tool that we built in 2019 to a modular framework, able to connect with other modules and be able to be extended without any major issue, let's say. Let's take a step back and see an outline on what are we talking today. Let's start from this outline. First of all, we will see what is TLS and why it is important, its ubiquity and its usage. Then I will show you how is it possible to misconfigure it and the issue that may come with these misconfigurations, and the actual problem we focused on, which is the lack of mitigation. Then I will continue by showing the tool we built in 2019, so the feature it has and the issues we detected during the years. And at the end, I will leave the floor to Matteo that will describe how we passed from that old version to the new one, highlighting the new features and how we fixed all the things we detected before. So let's start with, well, what is TLS? As you may know, TLS is a standard, stands for Transport Layer Security, and it is a suite of cryptographic protocols that ensure confidentiality, integrity, and authentication between parties involved. Its first version, TLS 1.0, came up in 1999, thanks to a joint work from IETF, Microsoft, and Netscape. Since that version, it has been enhanced 4 times, removing unnecessary features and also unsecure features, leading up to 4 existing versions up to today. As you can see from this graph, these are the current level of support each version has. As you can see, TLS 1.2, that was the latest version available for almost 10 years, is the most supported as of January, because this graph is from has been updated since January. And this has been taken from scanning the Alexa Stop websites by usage. TLS 1.0 and 1.1 are very old and very, let's say, broken. For that reason, last year, IETF published an RFC deprecating, officially deprecating them. So now we are not, let's say, supposed to use them, but you can still use 1.2 and 1.3. Why it is possible to misconfigure TLS? Well, TLS is not like a piece of software that you can install and have a default configuration. Being a protocol, you have to install the service, like the program that handles it, which is called web server, and then you have to configure it. So you have to configure the ciphers you want to offer to your clients, the protocols, so the versions, because you should choose between 1.2 and 1.3, but you can also at the moment choose previous versions, also the SSL versions, which are even older. You have to set various configuration and also cope with various implementation issues that the libraries like OpenSSL may have. So it's a big work. What can happen if somebody does not, let's say, properly configure TLS? This may happen. This is a part of an attack tree depicting almost every attack that can be performed against TLS 1.2. Let's see that almost all of them, if we remove specific legacy versions, none of these attacks can be done on TLS 1.3. But at the moment, given that TLS 1.2 is the most common, this can happen. As you can see, the attack tree shows on the top level, the root is the security property we want to break. The nodes in between show like the technology or the path. And the red squares, so the leaves, are actual attacks. Each one of them as a paper has been discussed and probably as a proof of concept either on GitHub or that can be found online. So now let's see why this is still an issue. This is a fragment of a report of a tool called Test SSL, which is a state-of-the-art tool. As you can see, the tool, this fragment, the report shows every check the tool has done, along with not vulnerable and vulnerable line, corolled if you want. But the very issue is that you do not understand that much from this report. So as you can see, for example, the report shows that crime has been detected on the web server. Crime is a vulnerability that exploits the deflate compression to, let's say, that uses the deflate compression as an oracle to get information about the cookie, the session cookie. So it's an issue. The report does not tell you how to fix it. So if you're a system administrator, you have no idea on how to fix it, and you have to study the literature and try to come up with a solution. Actually, the only vulnerable node is not enough, because as you can see, the crime vulnerability is very old. It came up in 2012. It is very difficult nowadays to exploit. So you see in the report that the web server is vulnerable, may be an issue, it may scare you, and you may want to report it to higher levels. But actually, you can ignore it if you have the proper prerequisites that avoid an attacker to attack you. So, given this issue, we came up with a tool called TLS Assistant. This tool was first released in 2019. Mainly, let's say the core feature of this tool, which is based on state-of-the-art analyzers, Test SSL 2, is the generation of a report that shows, for each vulnerability detected, a description on the attack itself. So it can help you understand if your machine is can actually be compromised, or if your specific configuration is not. A description of the mitigation that can be performed in a textual way. So in case of crime, it tells you disable TLS compression. And also the main part, the code snippet, which is a description, a set of steps that you as a system administrator can take, copy pasting and opening specific folders to fix the issue seamlessly. Given this first promising version, we decided to upgrade and continue to work on the project, and we released the first major version that added the generation of attack trees, like the ones I showed you before. In this case, when you want the attack tree output, you will be presented with 3 attack trees for confidentiality, integrity, and availability, showing which attacks of the full set of attacks can be performed on your service. Then we added new web servers analyzers for new vulnerabilities, and also the possibility to output in sticks, which is a way to share threat intelligence in a standardized way. And then finally, we added a new Android scanner able to perform more analysis for more, let's say, issues. But during these years, TLS Assistant 1.3 was released a couple of years ago. We realized that being written in Bash, it became monolithic and very hard to handle. So we decided to rewrite the tool from the ground up, using a different language and using a different concept like paradigm, focusing on 3 key points. The idea of having a flexible structure that could be extended either by us as developers and by others, using a set of APIs that we provide and standards. We had the wish to have a portable tool that could be versatile, fast, and easy to use. And finally, the need to communicate with external services. So either more tools built by you or by us, or even other tools built by other companies, with being able to be interconnected with a connector between the two of them. So for the next part, I will leave the floor to Matteo.
Okay, Given the point that my colleague just highlighted, we choose a set of requirements studying the use case that we came across. And we wanted a modular open source tool, a framework that was simple to use and supported the concept of mitigation that could be integrated with the newly identified vulnerabilities or features. We are also becoming familiar on what dependencies management is. It's important to have a clear, to find and have a clear list of which one we are using. So to make it easier, we just have one file that performs the installation, giving a type. For example, here we can just provide the Git type to download and obtain with Git the tool that we needed as a dependencies for the tool. We also choose to rewrite the tool in Python because we needed a solution that is interoperable and portable across all the computers that also may not have the bash executable. It's also easy to program, which this could expand the open source capabilities of the tool. As a result, we created this architecture, and we choose to categorize in different analysis module in different modules. For example, the analysis module, the wrapper module, the output module, and the core module. The module itself, it's a self-contained section of code with the specified purpose that if I remove one of the module, the software should work normally. The analysis module are the module that perform the analysis of the vulnerabilities, and this module will be loaded into memory by the core. These analysis modules as also the wrapper modules that encapsulate the calls to the external software or external APIs. And as you would expect, this part here generates raw output. So we have to pass to the normal analysis module to refine the output and make it human readable. This is the output module, and this is rather configurable because you can choose between HTML, PDF, and sticks compliant output. And because we can also analyze a lot of websites, we could have the repetition of the mitigation that you can see on the top, on the bottom part. And to solve the problem of the repetition, we can group by host. So we have a report for a single host, or we can also have by module, have a group by module with a part of the vulnerable websites for one single module. And what about the core module? The core module is just a router. It just takes in all the calls, the settings that we give into the software itself, and then it will be calling the module. It will be load the module into the memory, and will pass the result of this, the execution of the module, to the output module to be printed to the developer or the user. And this architecture has two primary flows, which we will now focus on this part of the flow, that is the end user flow, which can be customized as the end user desires. For example, the end user can run the tool by simply giving an endpoint to scan, such like this, but can also provide a list of modules to run in order to perform a precise, concise analysis on only the module, the vulnerabilities that we want to check. And even without a list of modules to scan, the end user can provide a file with a configuration file that can be systematically used to perform the analysis. This is an example that we list all the default possible vulnerabilities to scan. And we can also include one configuration in another or exclude one configuration recursively. Our tool is aimed at inexperienced user, but can also be used by corporation. For example, with the star symbol like this, star.fbk.u, we can scan all the subdomain and perform subdomain enumeration of all the website of the subdomain that has TLS. As simple as it seems, it just obtain all the TLS certificate of the subdomains and perform the scan for each subdomain. You may also give a domain list that can also have the star symbol, like here on bedssl.com. We can even examine a configuration file, nginx or a pash configuration file, and we can tell the tool to automatically scan it and obtain the good configuration. This is the after. And we can see that the tool added this configuration to remove the SSL 3 and 2 versions and remove the RC4, for example, cipher. For the developer flow, we asked ourselves some questions, such as how can a developer add a module? And how can we have a tool that is highly modular and also interactive, but allowing the car to run each module that we want to add? We need to focus on standards. So every module should have a file that informs the core where to locate the class name and the required module to load into memory. And it will also provide some default name of modules, of methods, such as run, with the arguments to pass to the module. So to answer the remaining question, a developer must follow the standards and put a Python file of the module in the modules folder and just add the configuration file. So it's simple as this. Someone can add another scan for another vulnerability, such as Alpaca that was recently discovered. Another point that the last point that emerged is our analysis passive? Well, it's not, but even if it's not, we know not the risk to trigger intrusion detection system, since generally it's just a modified TLS handshake, so there is no issues with that. But we use a caching mechanism to perform the same analysis again and again in the same with the same results, unless the user want to force the flush of the cache. In conclusion, we created an open source modular framework that allowed us to modernize an existing tool and create a versatile framework for those who like to extend it. And we also improved the usability, creating standards, simplifying future integration, and creating a set of API for state-of-the-art tools that couldn't interact with Python. As future work, we want to create a dynamic risk assessment system to tell which is the riskiest vulnerability for a single system. And also we are trying to create a system that gives us the regulation and the standards with NIST and BSI compliance. And this concludes our presentation. If you have any questions, feel free to ask. Thank you for your time.